All right, problem number 4, everybody. We need to build the equation that goes with this hyperbola. Hopefully you guys can clearly see that the hyperbola is running left and right. All right, so if the hyperbola runs this way, what's going to be the equation that we're going to write? What's the standard form of this particular equation? Go ahead, Liz, tell me the standard form for this type of hyperbola that runs going left and going right.
X minus h.
X minus h.
And then y minus k.
Y minus k. They're both being squared. We're going to put a squared underneath the x's. B squared underneath the y's. We said equal to 1. That's the first thing that you do. All right, you got to figure out which type of hyperbola is it going to be opening side to side or up and down. If it was opening up and down, what would we do? We would simply take the y minus k and move what? Move it up front. All right, a squared always leaves out. Okay, a squared always leaves out. In a hyperbola, a squared always leaves out. Yes. Okay. Now, this point right here, everybody, what does this point right here represent? Right there, where the asymptotes cross. That's the center. Good. I heard you say. That's the center, which is the h, comma, k. So what is our hk value here, Miranda? 1, 3. So put 1, 3. If you hear mumbling in the background, it's probably Isabel and Liz working throughout the video.
Not at least.
Not at least.
All right. I wanted my name in there.
All right, fine. All right, so we have hk. So what I want you guys to do right now is put x minus, what is our h value? 1 squared minus y minus our k value is 3 squared equals 1. Now we still need to find our a and our b. Now, the distance, everybody, from here to right here. By the way, what is this point called on the hyperbola?
A vertex equal.
That is a vertex. Okay. And this point right here is the other vertex. All right? So what is this? This is our a value. What is our a value in this particular case?
1.
1. Our a value is equal to 1. 1 squared is 1. We're done. Now, what I told you yesterday was how do we build our rectangle that helps us with our asymptotes? From the vertex, go up until you reach your asymptote and put a point right here. Or go down from your vertex and put a point. So go down and go up. Now that allows you to build the rectangle where your asymptotes. There we go. So there's our rectangular box right here where the asymptotes go through that, cross through the exact center. All right. What's the distance from here to right there and from down to right there? What? That's 2, right? Well, what does that represent? That represents our b value. So those are our b values. Remember, this right here, everybody, is your transverse axis. This is your conjugate axis. All right. So our b value was equal to 2. So b squared is 4. And this is your final answer for number 4. Now, I didn't ask you to label the foci. If we wanted to label the foci, then we'd have to solve for c, and the equation that you would use would be c squared equals a squared plus b squared. We're going to use this equation later on in some problems that we do on the back part of your assignment. Okay? Okay. All right, number 5, everybody. It says, write an equation of the hyperbola for which the length of the transverse axis is 8 units. I want you to highlight this or underline this. By the way, the transverse axis is always equal to 2 times a. So 2 times a is going to be equal to 8 units, which means our a value has to equal 4. If you were to make a coordinate grid on your paper, it's called the x-axis. Call that your y-axis. You have x and y. That's not a very good y-axis. Alright? Label this your x, label this your y. What I'd like you to do is plot a couple of points. It says the foci, right here, the foci are located at 6, 0, and negative 4, 0. So right over here, we'll call this, right here, we'll call this 6, 0. And right about here, we'll call that negative 4, 0. What board should we sit? Negative 4, 0. You can call this focus 1. You can call this focus 2. By the way, directly in between, what's going to be the midpoint between the two foci? What's the midpoint called? By the way, what's the gap between a negative 4 and a positive 6? How many units? The distance between a negative 4 and a 6 is 10 units, and half of it is 5. So if we go back 5 units right here, what ordered pair am I going to be at directly in between the two foci? I'm going to be at a 1, 0. What does this 1, 0 represent in the hyperbola? That represents your center. So there's your center. So what I want you guys to do right now is put h, comma, k. All right, h, comma, k, which is 1, comma, 0. Now, if the foci are located on the left and the right, okay, that means your hyperbola, if we were to draw it in eventually, would probably look something like this, okay? Which means it's going what? Left and right. So what I want you guys to do is I need you guys to build your equation. X minus h squared over a squared minus y minus k being squared over b squared equals 1. Now we already have our hk. And we already have our what? We already have our a squared, don't we? Okay? So what are we going to write? We're going to write x minus 1 squared over a squared, which is 16, because our a value was a 4, minus y minus, I'm not going to put 0, I'm just going to put y squared, over, so what's the only thing we need? The only thing we need right now is our b squared. So look at, right now everybody, if you guys write this down, look at your picture on the front of your page after you've written this down. So you're going to go to the front page, okay? You're going to look at a little drawing right here. Zoom in. Okay? So there's the drawing that's on the front of your page right here. Alright? And I want you to notice, right here is the center of this hyperbola, and right here is a focus of the hyperbola. And what do we call the distance from here all the way to the foci? What's this distance? Say, that's your C value. So what you need to understand is the distance from your center to a focus, that distance is equal to your C. So go back and look at our picture. That's right. So from here to here, everybody, that's 5 units. That is your C value. So right now I want you guys to write C equals 5. A, we already figured out was 4 because that's half of your transverse axis. Okay, so now that we have C and we have A, there was a formula I said we were going to use from the last problem. What's the formula?
C squared equals A squared plus B.
That's right, A squared plus B squared. If I said A squared minus B squared, that would be what? That would be dealing with an ellipse. Okay?
So now you have to find B squared.
So what is C squared?
25.
45. A squared was 16. Hey, look. 16 plus what is going to be our b squared?
9.
And that's what goes there. And this right here is your equation, everybody. This is your equation. This is what you're doing, everybody. When you guys are working through these problems, this is what you're doing. Now, something we talked about yesterday, all right? Because you also have to deal with this concept called eccentricity, all right? And eccentricity right here, everybody, is equal to what? It's equal to C over A. So if they've given you the eccentricity in a problem, make sure they've basically given you your C value and your A value. Okay, so if you see a problem that has that, just know you just found your C and your A. What formula can you use to find B? That's C squared equals A squared plus B squared. All right. What I want you to do is use the clues that are on your paper and solve the rest of